Okay, this video we talk about the solution for assignment 10. So we have two questions, so let's begin. So yeah, for the first one, the circuit is look like this, and actually we need to find the current I here, which is the current going through the voltage source. And actually we cannot write any formulas about the current of a voltage source. Likewise, we cannot write the voltage difference across a current source. So actually we need to solve for the whole circuit, and after that we can calculate all the current, and then finally we can use the KCL at this node, and then we can find I. So in this question, no matter you choose to use a mesh analysis or node analysis, actually be three variables. Let me show if we use mesh equation, the current will look like this. This is the first one. This is the second one. Well, this is the second one, and actually this is a super mesh. So you can regard this one to be a super mesh. Actually, this one is the super mesh, and maybe I can call this one I1, I2. This one is I3. This one is I4. So we can write a mesh equation here, another one here, and then the other one here. And finally, we also have I2 minus I1 equals 4. This is 4a, so I2 in this is pointing upward, and I1 is pointing downward. So I2 minus I1 equals 4. So actually, after eliminating I1 or I2, then we can write three mesh equation with three unknown. So this is the way we can use the mesh analysis. And if we use node analysis, similarly, we can assume this one to be V1, the node 1, and this is V2. This is V2, and this is 3. Okay. So actually, we can write three node equation. Okay, for the first one, for the node 1, so first one is V1 minus 30 over 4, which is the current going out from V1 through this 4 ohm resistor. And the current going from node 1 to node 3 is V1 minus V3 over 8. And this current is going in, so equals 4. And for node 2, this current going to the left side, V2 minus 30 over 2. And then this current V2 over 3. And this current V2 minus V3 over 6. And then this 4a also going out. So plus 4 equals 0. And then for node 3, we have this current V3 minus V1 over 8, and then this current V3 minus V2 over 6, and then this current V3 over equals 0. So we write also similar to the mesh analysis, the node analysis also, we can also use the node analysis to write three equations with three unknown, V1, V2, and V3. So actually we can just simplify it a bit. So for node, for equation 1, we have 1/4 plus 1/8 V1 minus V3 over 8 equals 23 over 2 over 2. So we multiply both sides by 8 by 8. So we will have 3V1 minus V3 equals 92. And for the second one, we have 1/2, 1/3, 1/6 multiplied by V2 minus V3 over 6 equals 11. We have 4 and then minus 15, so 11. So we can multiply both sides by 6. Multiply both sides by 6. So we have 6 V2 minus V3 equals 66. And then for the third one, we have minus 1/8 V1 minus V2 1/6, and then plus 1/8 1/6 1 over 1 equals V3 equals 0 So we can multiply both sides by 24. So finally we have minus 3V1 minus 4V2 plus 31V3 equals 0. So this three equation can be simplified like this, and actually you can write that V3 equals 3V1 minus 92, and 3 no, not this way. You can write V1 equals V3 plus 92 all over 3, and then V2 equals 66 plus V3 all over 6. And then these two equations can substitute here, and then we can eliminate V1 and V2. So only V3 here, so that we can solve. We can actually solve that. V1 equals to 32.21 volt, and V2 equals to 11.77 volt, and V3 equals 4.64 volt. So actually we can we can now calculate any voltage or current in this circuit. So actually, we can use KCL at this node. We know that I equals to this current plus this current. So this is 30 minus V1 all over 4, and then 30 plus 30 minus V2 all over 2. So we write it here. So finally, we can write that I equals to 30 minus V1 all over 4 plus 30 minus V2 all over 2, and equals to 8.56 A, not V. A. So this is the answer for question 1. For question 1. Okay. So the next one we can use we're supposed to find Vx, the voltage across the 10 ohm resistor. So actually we can use the source transformation. We can use source transformation. Actually, you can find this method in part 3 of this week's notes or videos. Okay, so as we need to find Vx, so even during the source transformation, we hope to keep the 10 ohm resistance here. Otherwise, we may lose this stuff. So first of all, this part is definite equivalent circuit. Also, this part is definite NEN, definite equivalent circuit. So let's draw the other part without changing anything first. So we have a 10 ohm resistance here, and then we have 60 ohm, and then this is 6A, and then this is 30 ohm, and this is ground, and this is the original circuit. So we have just copy down the original circuit. So we convert this part into the Nortons. Norton. So the resistance doesn't change. So we have 30 ohm, and then series with a parallel with a current source, and as you can see here, the voltage source is this side is positive, this one is negative. So the current is going upward, and the voltage source will be nothing but this is 90. So 90 over 30 equals 3A. So this part is transformed into the Norton's equivalent circuit. And for this part, we have 20 ohm, 20 ohm. Resistance doesn't change. And then this voltage source pointing upward, so the current source also pointing upward. And then it is 40 volts over 20 ohm, which is 2A, 2A, like this. So we can further simplify this circuit. These two resistors are in parallel, so 30 parallel 60 equals 30 times 60, 30 plus 60. So this is 1A00, this is 90. So it is 20 ohm, 20 ohm. And for this part, 30 parallel 20 is 30 times 20 over 30 plus 20. So this is 600 over 50. So this is 12 ohm, 12 ohm. And also we have this one is 6A, and then this one is 2A. So all of them are pointing upward. So we add them together. 6 plus 2 is 8A. 6 plus 2 is 8A. So we can redraw the circuit like this. This is 3A. This is 20 ohm, 20 ohm. Or maybe I can draw green color. Green color, 20 ohm. And then this is 10 ohm. And then EX plus minus. And then the resistance is 12 ohm, 12 ohm. And then finally the current source is HA. So here we have this one to be a Norton equivalent circuit. This one is a Norton equivalent circuit. This is Norton. This is Norton. And then we change it to Thevenin. So the rest of the circuits remain this 10 ohm resistor, Vx, something like this. This is ground. This is ground. So like this. So this part we have 20 ohm. 20 ohm. Sorry, we need to change it into the Thevenin so that it will in series 20 ohm. And then this will this current source is converted into a series voltage source. And this is 3A, this is 20. So this is 3 times 20 equals 60 volt. And for this one, we have 12 ohm. And then this one is HA times 12 ohm equals 96 volts. 96 volts. So this is 60 volt. This is 6 volt. 60 volt. 60 volt. This is 96 volt. So you can imagine that This is a 3 series resistor, so you can imagine that this voltage, the voltage at this node is higher than the voltage at this node, which means that Vx should be negative. Vx should be negative. So we can write that Vx should be 60 minus 90. Because you can imagine this is a series resistor. This is series resistor. So this voltage minus this voltage is the voltage difference across the equivalent resistance. So 60 minus 96. And then the current going through it is 20 plus 10 plus 12. So this one divided by this one is the current. It's the current going through here. And then, so this is the current. This is the current. So Vx should be the current multiplied by 10 ohm. By 10 ohm. So we can see that it is minus 8.56, 8.57 volt. This is very interesting. This is very interesting. As you can see that for the first one, the answer is 8.568. And then for this one, minus 8.57 volt. Maybe it's a coincidence, but well. So actually, in my opinion, the question in this week is quite simple. And if you have any further question about the circuit analysis, please let me know, and I'll try to reply to your question. And I'll see you next time.